Hello, this presentation provides an overview of the resources and services available at CHPC, the Center for High Performance Computing at the University of Utah. If you have any questions about this presentation or the services we provide, please see our documentation at www.chpc.utah.edu or contact us via email at helpdesk@chpc.utah.edu. CHPC's mission is to engineer and operate cost-effective and high-performance research computing and data resources for the university communities we support. We continue to do this in a rapidly changing and heterogeneous information technology landscape. We also seek out opportunities for workforce development and continuous learning for our student employees and professional staff. Finally, we provide a robust set of services to support researchers, which include user support, training, and documentation. Who are we? Our staff includes 30 full-time professionals and 18 part-time students with a wide variety of backgrounds in the sciences, engineering, and management. We have expertise in scientific computing, computer networking, data storage, software development, and system administration. How can we help you? Perhaps you need assistance implementing parallel processing on a large-scale problem, or you need access to a single high-powered computer, or need to run many individual jobs simultaneously. We have resources to help with all of these tasks. CHPC can assist with storing or processing a large volume of data. We can host software that you may not be able to run on your own computer. Perhaps you need to process sensitive or restricted data, such as protected health information, IRB governed data, controlled unclassified information, or data that is otherwise sensitive or restricted. CHPC has computing environments appropriate for these data sets. CHPC offers a variety of resources and services to meet these needs, such as computing clusters, data storage facilities, Windows servers, virtual machines, a protected computing environment, networking support, and user support. Let's look at each of these types of resources in detail. First, let's discuss the computing clusters. CHPC has constructed 5 computing clusters, 4 of which are located in our general environment for unrestricted data, and 1 which is in our protected environment for sensitive or restricted data. Together, these provide access to over 38,000 CPU cores in our general environment and over 8,000 cores in our protected environment. All of our clusters are operated in a condominium model, in which each cluster contains a number of servers or nodes purchased by CHPC, which are available to all users, alongside nodes purchased by individual principal investigators or departments. Users with a time allocation on the clusters receive priority access to the CHPC nodes on the Notch Peak and Granite clusters in the general environment and the Redwood cluster in the protected environment. There is more information about time allocations near the end of this presentation. Nodes purchased by faculty or departments are available at any time to the purchasers of those nodes, but idle time on those servers is made available to all users on a preemptible basis. All of these clusters include interactive nodes, which are a landing zone for new user sessions, as well as compute nodes, which carry out the bulk of the computations, specialized GPU nodes equipped with graphics processing unit chips, and finally, data transfer nodes for high-speed data transfers to or from off-campus locations. Access to the compute and GPU nodes is managed by the Slurm scheduling system, which locates computing resources in the cluster to meet your particular needs and releases those resources to another user when your work is complete. With a CHPC account, you can access these clusters via software such as SSH, FastX, or the Open On-Demand web portal. The vast majority of this computing hardware is located at our downtown data center in Salt Lake City. This facility came online in 2012, and CHPC completed its move to the DDC in the spring of 2013. We share this facility with the University Enterprise Computing Resources, which handle academic and hospital computing. CHPC's resources comprise 92 racks of equipment and consume 1.2 megawatts of power, with an upgrade path for additional capacity. Additional cooling capacity is scheduled for installation early in 2025. This data center has a high-speed fiber optic network that connects campus, the data center, and the internet. It is staffed 24 hours a day and provides CHPC with power, cooling, network connectivity, and security. If you're new to a clustered computing environment, this diagram will give you a sense of what the experience is like. From your client machine, which might be a laptop or desktop computer, you can connect to one of the interactive nodes on the cluster via software such as SSH, FastX, or the on-demand web portal. Each of the clusters has at least two interactive nodes. In this example, showing our cluster named Notch Peak, the interactive nodes are named notchpeak1.chpc.utah.edu and notchpeak2.chpc.utah.edu. This naming convention applies to all of our clusters. Once you have connected to an interactive node, you can use commands in the Slurm system to submit a request for computing resources for your work. Depending on the resources you request and the state of the cluster, your request may be fulfilled within a few seconds or up to several hours, again, depending on the specific resources that you need. We have documentation and offer free courses every semester about the use of these tools to access and use the clusters. The Open On-Demand web portal is a popular alternative to SSH and FastX software packages for accessing the clusters. With On-Demand, you can use a web browser to manage your files at CHPC, manage jobs on the clusters, and access popular applications such as RStudio Server or Jupyter Lab running on the compute nodes of the cluster. We offer a class about On-Demand in our series of classes every semester. We also have documentation on our website about this. The Slurm system, which stands for Simple Linux Utility for Resource Management, controls access and schedules jobs on the cluster. When you use Slurm, you request the kinds of resources you need, for example, the number of CPU cores and the amount of memory you need and for how long. And Slurm will make those resources available to your job. If those resources are not immediately available, your request will be queued to wait for the resources. Slurm is accessed with a few simple commands, for example, sbatch or salloc to start a batch or interactive job. Scancel is used to cancel a job. SQ is used to check the status of jobs. There are several other commands that are used less often that are part of the Slurm system. CHPC has provided several easy alternatives, such as myCHPC to show your access to the clusters, mySinfo to show the status of those resources, and MySQ to show the status of your jobs. Now let's discuss data storage at CHPC. We offer several different classes of data storage. First, we offer home directories, which are spaces for your personal files. This space is free to all CHPC users. We provide up to 50 gigabytes of home directory space, which is not backed up. Research groups can purchase additional home directory space if desired, which we sell at a rate of $900 per terabyte of space for 5 years. And this does include a nightly backup of the data with a 2-week retention time. Another class of storage is group space, which is storage shared by a research group for all the users of the group to use for long-term storage of files. We sell this space in increments of 1 terabyte and charge either $450 per terabyte for 5 years, which includes a backup, or $150 per terabyte for 5 years without a backup. Yet another type of storage is known as scratch space. Scratch space is available to all users for free, and users have a 50 terabyte quota, meaning they may use up to 50 terabytes of scratch space at a time. This space is intended as short-term storage, so it is appropriate for temporary files generated during an analysis. This is not for long-term storage of data or software. Any files older than 60 days on a scratch file system are automatically removed to make space for other active users. We have several scratch spaces in the general and protected environments. There is also local scratch space located on each compute node, which is typically 1 terabyte in size or less. This space is for your active Slurm jobs only, as it is cleared at the conclusion of each Slurm job. Finally, we offer archive storage for long-term data storage. Archive storage is similar to cloud storage and is available for purchase at a rate of $150 per terabyte for 5 years. This storage is located on-site in the downtown data center. With the exception of the local scratch storage, files located in any of these data storage classes are available on all of the interactive and compute nodes within the clusters. CHPC has several large Windows servers available to you if you need to run Windows-specific software on a large machine. We have 2 Windows servers. Beehive is located in our general environment and has 48 CPU cores with 512 gigabytes of memory. Narwhal is located in our protected environment and has 24 CPU cores with 512 gigabytes of memory. Both of these machines have a variety of Windows software packages installed, for example, SAS, R, Stata, Mathematica, and MATLAB. If there is another package that you need, please contact us. We may be able to install that software for you. We also offer virtual machines, which are available for other applications that aren't appropriate for a clustered computing environment. Virtual machines are great for hosting websites, hosting databases, Git repositories, and so on, which can't be hosted well in a compute cluster. We have several community virtual machine servers for databases or websites, which are available free of charge, or you can rent space in our virtual machine farm. The prices for these virtual machines vary depending on the size of the virtual machine you need. So please take a look at our documentation or contact us if you have any questions. The computer network that connects the resources at CHPC is a high-speed, reliable, and low-latency network. This makes several things possible. First of all, our clusters can run multi-node jobs using the Message Passing Interface, or MPI libraries. This allows communication between compute servers working on the same large problem. Second, this network provides access to all of your files from any server within the cluster, so you don't need to move your data to a server processing the data. The data are already available to that server. Finally, this enables high-speed data transfer nodes on which you can use software such as Globus, rsync, the SRA Toolkit, or Aspera to transfer data on and off campus at high speed. CHPC offers 2 secure computing environments, the Protected Environment, or PE, and Citadel, our CMMC enclave. The PE provides dedicated secure resources for handling protected information, such as protected health information. As of early 2025, the security requirements for controlled access datasets from the National Institutes of Health are becoming much more rigorous, and the PE is undergoing a security upgrade to meet these requirements. This environment includes a cluster named Redwood, a virtual machine farm, its own data storage, including group space, scratch space, and archive space, as well as its own Windows server named Narwhal. Our second secure computing environment is named Citadel, which is a CMMC enclave appropriate for controlled unclassified information. If you have a project that requires this level of security, feel free to contact us. The CHPC servers host over 600 different software applications covering a variety of scientific disciplines. We typically have multiple versions of each package, and most, although not all of these packages, are open source software. We manage our software through a system of software modules. There are several module commands you can use to find appropriate software modules and load them into your environment. We also have a variety of software compilers, debuggers, libraries, and container runtime systems for creating or running software. We use the Git system for software version control. And we host a local software repository named GitLab that you can use to host software projects. We also have recent copies of the CUDA libraries and drivers installed for GPU programming. Finally, if there is a software package that you need that we don't have installed, please ask us. We may be able to install that software for you. You also have the ability to install software on your own at CHPC. You're welcome to use package managers such as Anaconda or Mamba at CHPC, as well as the pip system for managing Python packages. The R statistics software can be used for installing R packages. Also, you have the ability to create your own software modules that work with our module system. We offer a class on this as part of our presentation series every semester. So what does access to all these resources cost? Most of our services are provided free of charge. Accounts are free, which provides access to the clusters, a home directory space of 50 gigabytes, access to Scratch space, and to access to all of our training classes, support, and consultation. Shared group spaces can be purchased for $450 per terabyte for 5 years, which includes a backup, or $150 per terabyte for 5 years without a backup. Virtual machine costs vary depending on your needs. Some community servers are free for website hosting, for example. Others vary in cost, starting at $425 for 5 years. CPU compute nodes can be purchased and added to the clusters and can be set up as dedicated compute nodes under Slurm control or as interactive nodes. Prices vary, so please contact us for a recent quote. And finally, GPU nodes can be purchased and added to the cluster as well. Their costs vary dramatically depending on the type and number of GPUs you need, so please contact us for quotes. So how do you get started? You will need a CHPC account, and you can apply for one on our website, www.chpc.utah.edu. From that page, navigate to the documentation/getting started page. You will need a University of Utah UNID to apply for an account. If you are a student or faculty person from another Utah university, please see the section on affiliate accounts. Affiliate accounts are university UNIDs available to you at remote sites. Once you've applied for an account, we will obtain approval from your principal investigator, confirm your email address, and will then provision your account. Earlier, I mentioned the time allocations on our clusters. Time allocations provide priority access to the CHPC nodes on the Notch Peak, Granite, and Redwood clusters, and to the GPU nodes on the Granite cluster only. We offer several sizes of allocations on a quarterly basis, as well as quick allocations, which can be set up at any time. Time allocations are managed on a per lab basis rather than a per project or per individual basis. So all the projects for a lab will use the same time allocation. You can learn more about our allocation process from our website, which is www.chpc.utah.edu, by navigating to the User Services Allocation section. Finally, we offer user support in several forms. First, we offer a series of classes every semester via Zoom. This series covers a variety of topics from basic cluster use all the way up to advanced parallel and GPU programming. These courses are free and open to anyone. Next, we provide documentation about the clusters, software, and other resources at CHPC, and this is available via our website, www.chpc.utah.edu. And finally, we offer assistance via email and face-to-face consultations. The best way to reach us for this type of support is through our help desk email, which is helpdesk@chpc.utah.edu. Thank you for listening to this presentation. We look forward to assisting you with your computing needs. If you have any questions, feel free to reach out to us at helpdesk@chpc.utah.edu. Thank you.